but I guess it really hasn't been done. Somebody will do it. Yeah. Read Frack. Frack will tell you all about it, and it's an excellent resource anyway. So, good stuff. Huh? It'll give you this error. I think I can actually make that error happen real quick, which is basically failed check. And it'll say which point of the check it failed. The beauty part is this is all open source, right? So you can take a look at what those checks are, and it'll check against things like AV, dereference system map, and things like that, which are values which are just logic values. All right, I know I have this much memory, and logically this program shouldn't take more than this much. So is it less than that, the size of this chunk that supposedly belongs to this program? It's really hard to get past this. The best guy I know at this kind of thing is this guy No Life on DARPA, and Gara's insecure programming challenges are a collection of like 60 exploitable chunks of code, including malloc stuff, double freeze, all that sort of thing. He wrote an exploit for ABO 9, Advanced Buffer Overflow 9, which is basically malloc, and it's really interesting. You can Google around for it, and it's good stuff. But anyway, I gotta get going here. Previously explored capable fitting in system memory. Is a valid address stored in an offset? You can tell pretty easily if you have a valid pointer. It should fall within, you know, some basic ranges. Arrays. All right, this is wrapping up here. X has a number of elements equal to Y. Okay, so the kind of element has to be defined. So if this is int X, then it has, in this case, 10 ints, which are a specific size. If it has 10 characters, it has 10 ints, which are a specific size. In this case, in C, providing an array index literally translates to an offset of the expected size of the element type multiplied by the array index we give it. So if it expects the element to be 4 bytes and you specify 3, then it will do 4 times 4 to figure out how many bytes your offset should be from the base pointer of the array. And the reason I say that is because x3, we start counting a 0. 0, 1, 2, 3. It's 4 elements. So if I write to offset more than 9, because we start from 0, that would be 10, really. You always have to consider that when doing array indexes. You can smash stuff. You can go anywhere you want in memory. What's really hard is figuring out what should be in memory and then recreating it, which is often necessary. Keeping stuff intact, big chunks intact, and then writing just where you want to create noise, and then a big chunk intact. It's really hard, and it's often necessary for one reason or another. This is just sort of you know, being mean, but argc is how many arguments you have. So if argc is more than 0, exit, and then copy argv100 to a buffer. This is actually in a challenge. Just to give you an idea, like, well, I shouldn't really tell you this, but exec.le lets you specify an environment and variables and stuff. So there's a lot of different ways that you can make these exploits harder. That you can make them tricky to pull off. One of them is keeping memory intact, and you know, C Unix, at least a concept of ASM, assembly. And I would suggest GDB, GCC. strace is really cool. It shows you all of the system calls being made by the program. Fuzz will throw a bunch of noise at a program. I don't use it, but I'm sure it'd be helpful if you were really just barely getting into it and wanted to do something. Perl, you don't need to know much. Perl. And Frac. Frac is a resource, is an excellent resource. I'm going to plug them one more time. They're about to print their last, I guess, volume or article or magazine or zine. So go to their website before they die just so you can say you did. And my bibliography is Google. Seriously, this stuff is all very, 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 very public domain. It's just hard to learn on your own. It takes a lot of dedication. It takes a lot of sitting there failing. These levels take months, sometimes, if you suck, to complete. You will complete them. You will eventually understand what's going on, even if it's not the way that you would normally look at a program and figure out what's going on. So keep at it. The rush you get when you beat it will be awesome. And it's good stuff, and you'll learn a ton about computers. A ton. So thank you. Any questions?
Coming in, did you know that you were in competition with Irish and myself? Not myself, but me, for the worst slides in the competition?
Did it win?
I think I won, but you got pictures. Yeah, but I give you.
Do we need to vote?
Sorry, I just wanted to see if you knew that you were in competition.
I didn't, actually. Yeah, they were informative. Come on. I don't like color. It scares me. Confuses. Any other questions? Not concerning the quality of my slides? Preferably. All right. Thank you very much. Let's wrap up.